All right, welcome back. So, we have position x coordinate of the particle moving the line y equals 2 is given by x of t, where t is time in seconds. T is greater than 0 and x is on the position in feet from the point 0, 2. At what time is the particle at rest? So when we're talking about particle at rest, we're talking about v of t. And we know v of t is the first derivative, so that's going to be 6t squared minus 42t plus 60. We're going to set particle at rest. We're going to set the velocity equal to 0. So now we have 6t squared minus 42t plus 60 is equal to 0, leaving you with t squared minus 7t plus 10. Factoring that, that's going to get, so we get t minus 5, t minus 2 equals 0, so t is equal to 5 and t is equal to 2. So the particle's at rest at those two times. At what time is the particle moving to the right? So we know this is our v of t number line. So we know that that's 2, that's 5, it's a parabola, and that t is positive. We know it has that shape, so we know that it's going to be moving to the right from 0 to 2 and 5 to infinity. It's going to be moving to the left from 2 to 5. Now, I told you that maximum speed was not on the exam, but I am going to do the question nonetheless, just to make sure that you understand it. So we have maximum speed. Maximum speed is going to occur when the acceleration is equal to 0, so we know that a of t is equal to 2t minus 7. And so we have t, 2t minus 7 is equal to 0, is when t is equal to 7 halves. We're going to check that on number line at 7 halves. It's negative and then positive, so that we know that the acceleration is decreasing and increasing gives us a 0 at that point. So therefore it has a maximum speed, part D, at the time 7 halves. Now we want to know the maximum speed. The maximum speed for us is when the absolute value of the velocity. So the absolute value of the velocity at 7 halves is equal to 7 halves in that function. So that's the absolute value of 7 halves squared minus 7 times 7 halves plus 10, which gives us 2 1/4 feet per second. Total distance traveled. Total distance. So we know that we're going from 0. So we're 0 going to the right to the value at 2 seconds. And then we're going back to 5 seconds. We're going back to 5 seconds. And then we're going back, we're going to continue on to 6 seconds. It's still going to be positive, right? No, positive. So we're going to go to 6 seconds here, and we're going to go this way. So our original plot for at 0 for our position is at negative 50. So this value is negative 50. At 2, when we plug in 2, you get 2. At 5, you get negative 25. And then at 6, you get negative 14. So we started at negative 50, we ended up at 2, came all the way back to negative 25, and then ended at negative 14. So that means our total distance is from negative 50 to 2, from 2 to negative 25, and from negative 25 to 14, gives us a total distance of 88. when you add up all those units. Good. Now this last question is actually a pretty difficult one. So we have, at what time is the particle at 10:2? Now since this is a function on the line y equals 2, and it's moving, that 10 is really where they meet. So for part G, what they're asking you is really, when does x of t equal 10 for part G? And so then we set up our calculator, so 2t to the third minus 21t squared plus 60t minus 50 is equal to 10, and you get that x value on your calculator to be about 6.6824. But that would be a calculator again, not on the exam, not on the exam, not on the exam, not on the exam. When is the velocity of the particle increasing? Well, it's reaching a maximum speed at 7.5, or so it's going to be increasing up to that maximum point. All right. Whoops. Okay, on this question for number 2, you have x of t is equal to t to the third minus 3t squared plus 9t plus 2. We want to know when the particle changes direction, so just like before, we're going to be taking the velocity, so v of t is equal to 3t squared minus 6t minus 9, and we're going to set that equal to 0. Factor out of 3, you're left with t squared minus 2t minus 3 is equal to 0. Factoring that, t minus 3 times t plus 1 is equal to 0, because this t is equal to 3 and t is equal to negative 1. The negative 1 value we can't have because that's less than 0. So we know that at t is equal to 3, when we look at our velocity line at 3, here's 0. Again, this is going to be negative. That's going to be positive when we plug values in. So therefore, we know it changes direction at 3. What is total distance from 0 to 4? So just like before, we have total distance. So we're going to be judging, we know the particle starts off at 0. It's going to go to 3 seconds. We're going in the wrong way. Sorry, let me erase that. I'm going to start off at 0. We're going to go this way to 3 seconds, and then come this way to 4 seconds. And so at 0, the particle has a value of 2. And at 3 seconds, the particle has a value of negative 25. And then at 4 seconds has a value of negative 18. So therefore, our total distance is from 2 to negative 25, which is 27, plus negative 25 to negative 8, which is 7. So it gives us, at the mop, total distance of 34 units, 34 feet. What is the particle's acceleration at t equals 2? So we know a of t is equal to 2t minus 2, and a of 2 is equal to 2. And again, not on the test, but what is the maximum speed? We want to know when a 2t minus 2 is equal to 0. That gives us t is equal to 1, so that means it's going to hit its max speed at when t is equal to 1, because that's the only 0 point we're going to have. Alright, good luck. Study hard.